Buongiorno, good morning. Today we have the pleasure to talk to Sir Paul Nurse, recipient of the Nobel Prize for Medicine in 2001 and at present director of the Francis Crick Institute in London and former president of the Royal Society. Good morning, Professor Nurse.
Good morning, Gabriel, but please call me Paul.
Thank you, Paul. It's really a pleasure to be in your presence. So let's talk about your book, What is Life? Why did you decide to write this book and to address to a wide audience?
Well, I think I decided to do that by going often to my local bookshop and looking at the popular science books. And what I realized was this, that there were often books, particularly in physics, that talked about the major discoveries in physics that people were, that the scientists were sure of, and where we have discussions of Einstein and relativity and quantum mechanics and so on. But in biology, we didn't focus so much on the great ideas of biology. We tended to have popular books that were always looking into the future. That is, this discovery is likely to lead to a new medicine in 5 years or 10 years and so on down the line. And quite often these things didn't really come to fruition. And I wanted to write a book which dealt with the principles of biology, as I saw them at least, and that we were going to be certain of. In other words, if we read it 30 years from now, everything I would say was likely to be mostly right. And that to try and communicate that to a popular audience, because I don't think they were being told about what we really knew about as against what might be happening in the future. So I think that was the major driving force for me to write it. And I had in the back of my head a sort of interested 15-year-old or 16-year-old who perhaps is interested in science, maybe not, who would pick it up. But then also a little bit further back in my head, anybody who had an interest in the world, the natural world around them. So it was really a popular audience I was trying to address, but with real focus on the ideas that we were confident would still persist 20, 30 years from now.
So you write about life, and now, as we know, we are in the grips of a global healthcare crisis. But in your opinion, why Western countries were not prepared to face it?
Well, this is a difficult question, and one I think we will, in the Western democratic nations, be discussing for some time forward, because we haven't done well. And I have to conclude that the major reason was that we were simply unprepared. And there was a complacency, perhaps, that the strength of our research and the strength of our research, which is very, very strong in the West, would cope with something like a pandemic. But it didn't take very much thinking about it to realize that because a pandemic disturbs the whole way society operates, and because you have to make very rapid decisions, that the only way to deal with it was if you were fully prepared, which we were not. And I can talk about the UK, which I'm familiar with. We had done various studies in the past looking at a potential pandemic, particularly an influenza one, and conclusions were made that we weren't prepared, and then nothing was done about it. And maybe the scientists and medics didn't make enough fuss, maybe the politicians didn't pay enough attention because they thought, well, this is something we have to dream about in the future, but we don't have to worry about it now. I'm just not sure what the reasons were. So one is a lack of preparation. The second is, I think, our our societies have struggled with this and this is less scientific and more political, have struggled with this because we're asking society, people, to do things like socially distance and wear masks and accept vaccination, which some think impinge on their personal liberties. And they have thought less about the society as a whole and just more about their individual freedoms. And as a consequence of that, we've seen what can only be described as face mask wars. That was particularly the case in the United States, of course, which really made no sense because it was clear, even if that there had been no clinical trials, that if you had a respiratory virus, that covering your mouth and nose up could be positive, and we shouldn't wait around 3, 4, 5, 6 months to test whether that was the case. And yet the whole thing became a political weapon, that if you wear a mask, you're one political party. If you don't wear a mask, you're another political party. And that was crazy. Now, if we compare with the East, for example, in China, in other countries, Taiwan, Hong Kong, and so on, these areas did really quite a lot better than we did, partly because they were prepared, because they had suffered epidemics in related viruses over the years before, so they knew how difficult it could be to deal with. So even quite poor countries like Vietnam initially did really quite well. And secondly, they were more prepared to obey social rules about social distancing and masks and so on, because they lived in more regulated societies like China, or were more respectful of their neighbors in the communities in which they lived. And that resulted in a different outcome too. So those would be my observations. But frankly, I think this will require quite a lot of thinking and heart searching, primarily to think more clearly about how in Western democracies, with a respect for personal freedoms, we can relate to science and technology, which is complicated to analyze, and come to the best decisions and implement how things should go ahead for that society as a whole. And I would look upon this as one of the great challenges of the coming years that we in the West have to deal with.
Are we bound to have new pandemics in the close future?
I think we are bound to have new pandemics in the future. I think it's very difficult to know whether it will be quickly or not. What I can comment is that in our world is so globalized that and people are being transported across the globe in hours or at most a day, that the risks of spreading rapidly are now much higher than they would have been 50 or 70 or 100 years ago. So that is going to increase the risk. Another factor that will increase the risk, which the experts are discussing, is that as our population is growing and we impinge more and more on the natural world, mixing with animals, normally wild animals that would have been more isolated, then viruses that are found in those animals are more likely to transfer to humans. It's just increases the risk of that. And that's almost certainly what happened with this coronavirus. And so I think that's going to increase the risk as well. And some, of course, argue that climate change, which will also disturb the natural world and human societies within it, may also affect this as in addition. So I think overall, I would say definitely we will have epidemics and pandemics, and I think they will increase in frequency. So it is more likely that it will happen more regularly than perhaps it has done in the past.
In your book, you write extensively about cells and DNA, but what's the real role of viruses in the process of life?
Well, I briefly discuss viruses because the objective of my book was, as I've already explained, was to talk about the great ideas of biology and then use those ideas to generate a definition of life. And I specifically spend a few pages discussing viruses because they live in this borderland between living things, which are obviously living, like ourselves, and non-living things, like a stone, for example, which obviously isn't alive. And viruses are living things in the sense that they can undergo evolution by natural selection, as we're seeing at the moment with resistant viruses arising. And that's one of the basic characteristics of life. But they're not independently living. They only can grow and reproduce inside the cell of another living organism. So they occupy this confusing borderland that they seem to be alive when they're inside another cell, and they have characteristics of life, including the ability to reproduce themselves and to undergo evolution by natural selection. But when they are outside the cell, they become inert, and they in fact become really like a crystalline chemical. And so trying to work out whether they are living or not has been complicated. In my book, I suggest, for example, that maybe what we should do is think about them as being alive when they're in another cell and essentially not alive when they're outside. Another point I make to try and think about viruses is we should fully recognize that we are, every living thing on the planet is dependent upon other living organisms in various ways. I mean, even us humans, we depend on obviously other living things to eat, plants and animals. We have many other living organisms, bacterial ones, that live on us or within us, some of which are performing important roles for us. So what that means is that every living thing nearly always is interacting and dependent upon other living things. In the case of a virus, that is extreme, very extreme, in that it can only grow and reproduce in another cell. In the case of an organism like ourselves, we're still dependent, but it is not so extreme. So that introduces the concept that there's a gradation from complete dependency, like a virus, to partial dependency like our cells. So they're the two observations I would make about viruses and their relationship to other life forms and whether they are alive or not.
And now the coronavirus is mutating very fastly, and some experts think that we could never reach the so-called herd immunity. What's your opinion about that?
Well, I think that we may not meet complete immunity across the population. I don't know whether that's the case, but I do think that with proper production of vaccines that can respond to these mutated viruses, that the threat of the virus will be very significantly reduced. I've mentioned already influenza flu. Influenza changes and mutates a lot, which means that when we get our yearly vaccination, which many of us receive, that is a vaccine that responds to the new variants that have been formed. Now, it turns out the coronavirus doesn't mutate that fast, but because it's infected so many people across the world, that means that there is variations occurring. And what we have to do is to be very conscious of those variants. We have to become aware of them by sequencing the virus, which, for example, we do in this institute here, and then we can predict what vaccines are needed. And the new vaccine technologies that we're seeing have been put in place with a number of the vaccines that are being used across the world now, they are vaccines that can be produced very quickly, changed very quickly, and then produced reasonably quickly. And so with a proper management of this, which I'm sure will involve the World Health Organization ultimately, we should be able to produce vaccines that will protect the world. But it's very important in thinking about this to realize that, that no country is an island. And it's no good that we have a good protection in Italy or the UK, for example, if we're constantly being invaded by new mutated viruses from the rest of the world. So this is a global responsibility that we can produce a way of working that will protect the world. And that's going to require a political solution that, again, we've not really fully grasped, but it will be important if we are going to get close to herd immunity.